Here is an explanation for the answer to final exam question number 60 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find it on page 429. We're talking about magnetic flux density here, and what is the standard unit of flux density, and we're given 5 choices. Well, the short answer to this question is D. The Tesla is the unit of magnetic flux density. The Tesla, named after Nikola Tesla, who was instrumental in dealing with magnetic phenomena along with Michael Faraday and others. What we have shown here is an illustration of a current-carrying coil of wire and the magnetic lines of flux produced by such a current-carrying coil, similar to the magnetic lines of flux that you would find around a bar magnet. The poles of the magnet, one of them here, one of them there. The current-carrying coil of wire creates a certain magnetic field quantity. That magnetic field quantity depends on the current in amperes and the number of turns in the coil. So that complete magnetic field quantity is a unit called the Ampere-Turn, or AT, capital A, lowercase t, Ampere-Turn. That would be choice A, but that's wrong, because we're talking about the density of the magnetic lines of flux. The Ampere-Turn is a unit which expresses the overall quantity of magnetism produced by a current-carrying wire or a current-carrying coil of wire. The same thing is true of choice B, the Gilbert. That is a unit similar to the Ampere-Turn, just a slightly different size. Volt per ampere? Well, absolutely not. That has absolutely nothing to do with this phenomenon. Volt per ampere would be resistance. Remember Ohm's law, R equals E over I. So a volt per ampere is an ohm. Certainly not ohms. And coulombs? Well, no, that's not the correct choice either. Coulombs are an entirely different phenomenon having to do with charge quantity, electric charge quantity, but magnetic field quantity, those are Ampere-Turns and Gilberts. But the density, notice here that the magnetic lines of flux, which are imaginary lines, they don't really exist as fibers in space, they're theoretical lines that sort of indicate the contour of a magnetic field around a particular object like this. Notice that the lines of flux are closer together near the coil. They also tend to be very, very close together inside of the coil and immediately off either end near the magnetic poles. The closer together the lines of flux are, the greater the flux density, and the greater, therefore, the number of Teslas that you will see at a particular point in space. The closer you get, generally, to this coil, the greater the number of Teslas. Whereas Ampere-Turns and Gilberts have nothing to do with how far away you are from the coil. That's an overall concept, the overall quantity of magnetism. But once again, the correct choice here is D. The standard unit of magnetic flux density is the Tesla.